All right, good evening, everyone. Today is yet another day for our class. Today we'll talk more on load balancing and its importance to the cloud infrastructure. So I'm sure most of you must have heard about load balancers a lot. You must have heard about, oh, this is a load balancer, load balancer. So like the name implies, load balancer balances load. You get. Um, so the main aim of the load balancer is to ensure load balancer. The main aim of the load balancer is to ensure that traffic is distributed across multiple backends. Now, remember when we were building that other infrastructure, I told you that ideally your live application is not supposed to be routed via the internet. It's just a proof of concept based on what we are planning on doing. But ideally, the application is not supposed to be routed via the internet. So what's the best way to do? Sorry, someone raising a hand. Okay. So the best way to achieve that is by putting your application in a private subnet and then making it auto-scalable. So implementing auto-scaling and then putting it behind a load balancer. So it is load balancer now that will, be able to reach your application. So now what is a load balancer? A load balancer distributes traffic to multiple backends so that no single server is overloaded. You understand? No single server is overloaded. It helps for high availability. So for a situation where one server is down, your traffic can easily switch because of it's connected to a load balancer to another server in another region to ensure that it is your application still stays up while you fix the other one. So this aims to improve performance and speed and spread load, spread load across the environment. Now, there are different types of load balancers. So if I do on create load balancer, you will see the different type of load balancer. There's application load balancer. This is the application load balancer. So the application load balancer, what they say here is choose an application load balancer when you need a flexible feature set for your application with HTTP. So if your application is routing, receiving traffic through the HTTP port, which is ideal, you use a load balancer for it. Because you use an application load balancer for it. So it's ideal for applications that you are connected with HTTP and HTTPS. It has a lot of features. There's what they call so this is actually ideal when you want to build like microservice application. For example, if you want to build like an application that has multiple services that you want to be calling at the same time. For example, now let's say an e-commerce store where /cat, goes to the cat section, /order goes to the order section, the price of the item goes to the price of the item. All those kind of microservice applications. An application load balancer is actually very ideal for those settings because it has what they call smart routing. So smart routing ensures that, okay, whenever you put a /this, it knows the exact server where that particular route you're calling is and goes all the way to that server without any stress, without any durex or anything. So that's the best part of using an application load balancer. So you're building an application, let's say you're building an e-commerce platform, or you're building a platform that has a lot of services combined, or not just a lot of services, you're building a platform that, you know, you want different parts, different applications connected to that platform to be accessible. So if application A is down in one what they call it, in one availability zone, it automatically switch to the same application in another availability zone and keeps running non-stop. So yeah, that's it. In a short form, that's what an application load balancer does. Then we have the network load balancer. Network load balancer is fast and it can scale to millions of requests. It can scale to millions of requests at the same time. So network load balancer is usually used for high performance systems. If you want to build performance systems, like games, where different components needs to be accessed at the same time. For example, now if you for example, now you're playing game, you can set the route to when you make this command, it should go left, all this kind of stuff. Those small settings need like an abstraction on their own. You get, so an application load balancer will not be able to handle such change, handle such dynamism. You understand? If there's a word like that. So that's why you go for the network load balancer. However, it is, like I said, it's for high performance systems. So it is not something that you use for your everyday basic everyday application building. Most people, and 80% of people use, because 80% of the applications that powers, there's 20% of the applications that power 80% of the internet. So most of them use application load balancers, because most people, what they use it for is just for, routing and high availability and stuff. So yeah, like I said, network load balancer is high performance and is very, very ideal for high performance applications. Now there's a gateway load balancer. Gateway load balancer is a combination of both the application load balancer and the network load balancer. And it is designed for deployment and scalability for virtual appliances. So if you want to build a system where as your application is scaling, as your application is scaling, you want your third-party appliance connected to that application to scale as well. You use what they call a gateway load balancer. For example, you are using a third-party firewall for your application. But as your application is increasing, you also want the firewall to increase as well. You want the firewall to increase as well. To scale, I'm using the word increase, to scale as well. That's where you use what? Gateway load balancer. It may sound complex in the beginning, but trust me, with time you understand it properly and get to know it. So there's also the classic load balancer. The classic load balancer is legacy. AWS doesn't really support it as much. You understand? So I don't think they will really allow you to do anything with it, but this is the best one. For worst case scenarios, you will use the application load balancer. Yeah, so now an application load balancer whenever you set up an application load balancer or a load balancer in general, it goes to what you call a target group. You understand? It goes to what you call a target group. So your load balancer is what sends the traffic to your target group. Now, what is a target group? The target group is a set of resources that a load balancer sends traffic to. So your target group can be a group of EC2 instances. Hold on. Sorry, I went to turn off the broad light. I went to turn off my gel. So I turned off the gel. It took the light back. So yeah, so a target group is a group of instances, that allow you to register multiple targets. And so yeah, basically, so when a load balancer receives traffic from the internet, what does it go to? It goes to the target group. Now, your target group is your group of instances or your group of hosts that this thing should send the traffic to. You understand? So if you receive traffic, someone goes to www.peter.com. You receive it in a load balancer endpoint, and then trickle it down to the target group. Now, in the target group, that it will now start sorting where exactly should I put. If all the instances in the target group are the same, you just choose one. Let's say you have 3 instances. You choose instance A and drop the load, and then the user will be receiving the settings in instance A. You get, user are receiving the settings in instance A. However, if you have a set of a setup where the instances are different, they have different services basically. Once you go on, okay, peter.com/about, to go and look for where the about is in the instance, and then send the traffic there. So that's basically what the target. So a target group is what houses, it's what receives, like the encapsulation that receives the traffic from the load balancer. Now you can see, if you say you want to set the target group, you see choose a target type. Choose a target type. You see instances. And you see IP addresses, you see Lambda function, see application load balancer. So you can receive you can set up a load balancer to receive traffic from a public load balancer. So there are 2 types of load balancers. I didn't mention that. There are 2 types of load balancers. There is the public facing load balancer, internet facing, they call it internet facing load balancer. And then there's an internal load balancer. The internet-facing load balancer serves internet-facing traffic, has public addresses, DNS name, requires a public subnet. Now, the internal load balancer is the one that within your. So, for example, now in your private subnet, you have multiple applications that in your private subnet now. You have multiple applications that you want to, your load balancer to reach. So you can actually set. Some people, what they do is they set. Okay, let me paint the scenario. When you receive traffic from the internet, it goes to your application. Now your application now needs to communicate with the backend, which is database rather. After communicating with the database, some people will now put an internal load balancer there in between the application and the database, so that for a situation where they're using multi-AZ, or they're using a primary database and a read database to be able to route the traffic properly. So this load balancer is inside the network, it is not facing the internet. So that's what an internal load balancer is. Then there is like I said, there's a target group. So Now, within this target group, there's also what they call the listener. So the listener is like, it's like the it's what they call the traffic. It's like a traffic controller. So that thing, that element that enables the load balancer and the target group know where to put, the application is the listener. So when you configure the listener, okay, so when you configure the listener is what listens. So, like I said, since application load balancer receives traffic from what port 8, when it sends down the traffic, when it sends down the traffic to the target group, it is the listener that is inside the target group that now goes to look for the application that is projecting port 80, or rather that port 80 is open. You understand? Then now connect the load balancer to that application. So that it is the listener that does that element, that basic element. So let me paint the scenario again. Once the load balancer gets your inputs, for example, your user at your www.xyz.com, once it gets the input, it will now trickle down to the target group. The target group now use the listener. Target group now uses the listener to now listen for and the part where the application in the server, which is the target, that port 80 is exposed. So when you build an application now, for those of you that are development, you open port 80. You understand? The application should be running at port 80. So it's going to look for the application that is running at that port that you specified it. Now project that. So it's like a request and response. So once you put your www.com, the answer will pick your listing, go to where the application is, the application where the port 8 is exposed, and then push it out back to you. That's why you see there will be a loading sign. That loading sign that you will see loading before you know your application is up. That is the request. That is the process that the whole thing has gone through. So yeah, any questions so far? Hold on, let me check these lights. Any questions so far? Okay, well, let's proceed. Yeah, so now next one is auto scaling groups. What are auto scaling? Auto scaling groups are group of instances that, so it's like when you put so I don't know how to open the scenario of a scale to you. So if you put an instance in an auto scale, now when you deploy, when you do your www.xyz.com, the server trickles down towards a target group. The command request rather trickles down to the target group. After trickling down to the target group, it will now look for a listener to look. So now that listener, that target group now is where you will set this auto scaling group. Now, auto scaling group is a group of instances that, like I said, auto scaling. So it listens for traffic size, traffic demand. You understand? Which is why it's always connected to the load balancer. So if there's a high traffic coming through the load balancer to the target group, and it realized that one server is not enough to handle that traffic. It is set to spin up another server. You understand? To spin up another server that will now, to now like shift the traffic to the second server, and the second server will now start serving this traffic. However, it goes on like that till you set, because when you're setting your auto scaling rule, you set your desired state. So let us see how you set it now. I'm not setting one, but I'll just show you how you set it. Auto scaling. Now this launch template. Now launch template is basically the AMI that you are using to use to spin up a new server. So for example, that set the assignment that we did, you can create a launch template that for every new server that is set up, it should So yeah, sorry about that. I needed to attend to something on my work. Anyways, yeah. So yeah, launch template. So like I think someone did that in as assignment where you use your user data. You use your user data, and then you just set up a launch template where whenever a new environment spins up, it should automatically spin up with these settings. So for example, now if you want every new environment that is spinned up to have Docker installed, to have Apache installed or something, what you just do is set it as a launch template. So let's see, create a launch template. So a launch template is basically the same setup that we will use. By the way, for those that have done the assignment, I hope you have deleted your resources. So please, and please, hope you have deleted your resources. Okay, that's by the way. Please, if you're not done your assignment, whenever you are done, once you have done the assignment and taken screenshot, delete everything. 2 people now submitted and they did fantastic. Very, very fantastic. They have already scored 100/100. Very fantastic job. It's making me happy. This launch template is basically the same setup with setting up an EC2 instance, because this is the launch template that it will use to set up every EC2 that will be within the auto scaling group. You get? So if we say, let's just say KCLC, then we can just put the description KC, which is KodeCamp launch template. Then you can see, yeah, so you can set it that for every server that comes up, it should be an Ubuntu server. So it's loading. I don't know why this is wasting time. Oh, see one thing about being an engineer. See time now, 7:30. I'm still handling calls. But anyways, everywhere good. All of you have the pace of it. I'm just back and forth. So we're having like some database migrations. So I've been willing to handle it since, but they're calling me to ask me question, which is valid. Sorry about the interruption. So now you do the same thing, keep it. But for a launch instance, you can decide not to use a keeper, but it's always best to use a keeper, especially if you want to be entering into the instance. So these are instances that we created in the first time we did this note. You can set the subnet, which is the private subnet of the VPC that you want to create. You can set it. You can set all these setups. So for every instance it's going to create, I'm not going to set, I'll just show you security groups, basic stuff. What was this one? So you can set it even in the now, here now, you can write a script here now. I think somebody did this thing, I was very impressed. What they did was the server that they put in their custom VPC, they wrote a script here to install Docker and Docker Compose. That's what they did. Then when the server came up, Docker was already installed. They now did the CI/CD into the server and boom, everything worked. So I was so happy when I was marking that assignment. I don't want to mention his name because it's on the top. But anyways, now you can write a script here that would install, let's see. Can say sudo apt install or sudo apt update -y sudo apt install, let's say Apache. So yeah, the script will run it. When you create a launch template. Once you create a launch template, any server that is being spun, if you go back to the auto cleaning group and then you refresh, you can see KCLT is here. Any server that is being spun up is going to use these settings that I set here. You understand? It's going to use the settings that I set here. Now this defaults now. This is showing, this is a, so one thing with auto scaling group is that you can always, add a new version. So if I want to like update the, the settings and the rest, it will turn to 2. You see latest, you will see 1 here, you see 2 here. But you will now see default. Default is the one that you always just want to a server to spin up. Then latest is, you will see 2 here. Latest, I mean, trying to say that if you have spawned a new change in the launch template, you get, if you have made a new change in the launch template, spin up the latest one instead. You understand? So you can see all the settings I said, keep a security group, blah, blah, blah. Now, here it's telling you the, all the setup you want minimum of. So for every new server you want to spin, probably want a minimum of 4 CPU. Let's just say 2 CPU, 4 to 4. Memory, let's just say 100 to 256. Let's just say it would spin it like that. The instance purchase. All these ones are just the networking shenanigans. Now, since it's an auto scaling group, you understand? Since it's an auto scaling group, you don't select, since it's an auto scaling group, you don't select only one subnet. It has to go multiple subnet because an auto scaling group is auto scaling availability zone, availability. So a particular resource can be in US61A. Second one, probably high traffic now, sends you to US61B, like that. So you set the auto scaling group. For our default West Virginia, we have 6 availability zones, but I just want 2. So that means the servers could have be created in A or in B, depending on the traffic. Then you go next. Now you can see no load balancer. It's telling you no load balancer. If I put attached to an existing load balancer, it will tell me to select the load balancer that I created before, but I didn't create it. I'll just put no load balancer. But when you are creating stuff like this, you also have to attach it to an existing load balancer. Now, this is the part I wanted everybody to even see, not all those control. You can see it's telling you desired capacity type units. That means it is going to scale by units. You get, it's not going to scale by vCPU or memory. So what does this mean? Whenever there's a high traffic, it's going to scale by unit. That means if there's one server, it's going to add another one. If there are two servers, it's going to add another one, which is making it 3 servers. If you say by vCPU, meaning that if one server has a CPU of 2 gig, it's going to scale it to 4 gig. However, it's still going to be that same one server. Memory, the same thing. It's going to increase the memory. When the traffic increases, it's going to increase memory. However, it may not be the fix of the problem. So it's telling you units. This units now is what would now desired capacity is 1. Desired capacity will always be 1. Or if you're running a load balancer, it should be 2. Then the minimum capacity will be 1, meaning that at the lowest of low traffics ever in your architecture, there must be 1 server running. You get. The max desired is if the heaviest traffic hits the application, the infrastructure, at most 5 should come up. But at the normal time, it's going to be 2. That's why it's desired capacity. You understand? At the most normals of time, it's going to be 2. That's why it's what desired capacity. That means at every given point in time, it's 2. But if traffic is too low, you can, drop it to 1. The 1 set will not even trigger because if 2 is the desired, 2 will most likely be what will just be there. You understand? The max capacity now will now be 5. You understand? So for every the traffic increase, it will increase from 2 to 3, from 3 to 4. You'll be seeing it increasing. Then all these ones are just scaling policies and everything, instance maintenance policies. You can set no policy. So no policy means that it's just normal scaling. Now this particular one, it shows you launch before terminating. So that means for if this particular one works when you want to only scale, when one server is down. So it will launch a new one before actually killing that other server and going to this new one. Terminate and launch, blah, blah, blah. So this one is no policy and the rest. Next. So this next now is add notification. So you can add a notification that for every time there's a need for every time there's a need for something to scale up. So there's a high traffic now and the auto scaling setup is about to be triggered. Send you an email. SNS topic is the setup used to configure emails, configure notifications. It's called simple notification service. It's used to configure notifications in your system. Understand? So when you put the SNS topic, what is not the one? There's currently no SNS topic here, but you can add your email. If you add the topic, you can add your email. When you put on create topic, you add your email. So it's telling you that you notify subscribers whenever instances launch, terminate, fail to launch. So this is actually good for situations where, you're the engineer in charge. Traffic is high. The auto scaling trigger wants to come up. Send you an email. So you will know, okay, at this point in time, an auto scaling wants to happen. You get. Then there is the next. So this is just next, basically. Create auto scaling group. I'll just show you how it looks like, but it may not work because of that my user data that I put. Now you can see ASG. Okay, this is ASG case. So this is the KodeCamp auto scaling group I just created. It's using the KCLT launch template. Instance at 0. Now you can see status updating capacity. Desired capacity is to mean that if I go to EC2 instance now, when this thing is done, I will see 2 instances running. Max 1, mean 1, max 5, 2 availability zones. Let's just wait till it comes up and then we'll create. I'm so happy for the people that did the assignment very well. Now I can understand. Now I'm sure you understand. When you do the assignment, you have a solid understanding of CI/CD. There's no question about it. To show you that when you push code, when the code is pushed, it will automatically trigger the pipeline, and then all the steps that you have set up go seamlessly. All right. Let me refresh. Still updating capacity. Let's check the EC2 section. You see, it's not running yet. It's not coming up yet because it has not triggered finish. Still updating. Updating capacity. So yeah, while we wait, that's all we need to know about auto scaling groups and the rest. Now let's go to one important section which a lot of people don't pay attention to a lot until there's a disaster, which is CloudWatch. I'm sure Karen will be excited to hear that because she has always been talking about CloudWatch in class. CloudWatch has saved my ass. Sorry to use that in my work for the longest time. CloudWatch has saved me a lot. She said yes. CloudWatch has saved me a lot. So let's go to CloudWatch. Now, in CloudWatch is basically monitoring, you set up monitoring your resource, set up monitoring, your application, set up dashboards to be able to see what's going on within your application and make the right decisions at that point. I actually got a gig where I had to set up a full infrastructure. I have to set up just very simple, setting up all the CloudWatch infrastructure for the setup. And it was crazy, but it was fun because prior to that, I only heard of CloudWatch and I have not done anything on it before. But that's by the way. Now, in monitoring, the whole umbrella of monitoring, there are 3 main concepts. There is metrics, logs, and traces. Have this at the back of your mind. Have this at the back of your mind. Whenever you're starting anything concerning monitoring, there are 3 main setups: metrics, logs, and traces. Now, first of all, What are metrics, logs, and traces? You may ask. Okay. Let's go there. Let's talk about it. Metrics we are seeing here, like the name implies, metrics, gives you a numerical measurement that represents the state of the system. You can see this is a metrics dashboard now for CloudWatch. This is the metrics dashboard. You can see your CloudWatch graph is empty because you don't have any resource to monitor. But this is your metrics dashboard. When you attach a resource to this, it will give you, you can see, search for any metric. Let's just say CPU, let's just say EC2. We want to monitor our EC2 instance. Now, inside this EC2 now, we'll do CPU utilization. It's nothing will come out sharp because there's nothing CPU by, for instance, metric. So you can see we have set, we have, this is metrics. These ones are instances that I've turned off. So this is EC2 now. We set up per instance metric. So inside this per instance, no, I'm going forward. Let's talk about the basics first. Metrics, logs, and traces. Now, metrics are numerical. So if you want to have a numerical representation of your data at a particular time, you understand, at a particular point in time, okay, what is my instance reading at this point? You understand? Okay, what is the amount of percentage of CPU that is being used? This is how the auto scaling occurs. You understand? Because it is by whatever CloudWatch feeds to the auto scaling group that it now triggers the need to auto scale. You understand? So it is from CloudWatch that it gets that data that tells auto scaling group, oh, see, traffic is getting too high, bros. Add one more instance to balance it, basically. So that's so I've taught you the full spectrum now. The full spectrum of load balancer to auto scaling group, CloudWatch. CloudWatch is the underlying factor to the whole setup. It's CloudWatch. Now there's metrics. It is one thing with metrics is that it is structured, it's quantitative, and it's aggregated, meaning that it gives you the data as it is. You know, can give you in graph, can give you in line form, you know, that whole setup. Now, it is used to detect trends and get threshold and trigger alerts. So if you want to, okay, what's the utilization of my instance? If this instance traffic is high, let me check the traffic, because you can never really know when traffic is high with the instance just showing there. It is through CloudWatch that you set it. When you set it, you will see that traffic is actually high. You get. Now let's go over to logs. Logs is a record. Now the difference between this. Now let's say metrics. Metrics, when we said, is what? Numerical measurements collected at regular intervals that represent the state of the performance of a system. That's metrics. Now, logs is a detailed record of events that happened in a system. The difference between metrics and logs is that metrics gives you the state of the system, the performance of the system at that point. Logs is like a trail of, at this point, this is what happened. So for every action taken, this is the result. So if somebody accesses your application and says www.peter.com, and it shows the person your site is a successful, it will record as success, the logs will record as successful. You understand? The logs recorded as a successful event. It will be recorded. You understand? If somebody now goes and then types www.peter.com and then he sees site not found or network error, the log will pick it. That's why most times if you hear people they are looking for a problem, when they say some site is down, what's the first thing they check? They check the logs. Because it's the log that will give you the details. Okay, the site is down because the database is down. The site is down because the database is not connected. That's the main aim of the logs. So for every instance you are deploying, you have to also deploy a good monitoring system for it. Most people are paid, they don't touch anything CI/CD in their life. They don't touch, they don't even come and start creating instances and all these things. What companies pay them for is just to monitor the system, set up proper monitoring, because if anything goes down, they are in trouble and they pay them big money. What do they call them? SRE. I'm sure people have heard of, oh, I'm an SRE, Site Reliability Engineer. Oh, I'm an SRE. That is the work of SRE. That reliability is mostly centered around setting up proper monitoring systems. That's it. So logs is a successful collection of events. You understand? Logs is a successful collection of events that happen in a system or application. It is not structured because it just gives you, you know, at least if you give it a timestamp at this particular point, it is used for troubleshooting, auditing, forensic analysis, and understanding exact sequence. So for example, now you want to troubleshoot a system, you probably want to build a better system. It is from the logs that you will know that, oh, see what is happening. See the pattern that has been happening. What can I do to avoid this particular pattern? That's when you now know what to implement or what not to implement. Do you understand it? Any question? So what did I say the component of a monitoring system? Metrics, logs, and traces. Please, everybody should write it down on the chat. Metrics, logs, and traces. Please write that on the chat or write that on the chat. Nobody is writing anything. No. Nobody is writing anything. People have dropped your computer. I'm talking too much. Can anybody hear me?
Sir, we are writing.
We can hear you, sir. We are writing.
Okay. How many people are writing? Yeah, only two.
Check the chat.
Okay, oh, no problem. Only two people have written so far. No wahala now. Anyways, people have made me now lose morale. But anyways,
So 5 people have written. 5 people have written.
Can you what? I can't hear you.
5 people have written something on the chat box.
Okay, oh, okay, no problem. Now there is also traces. Now, what does traces do? Traces is a record of the journey of a single request through a system. So I log into your system. I click the home button. I leave the home button and I click the about button. I click the about button and I click the service button. I click the service button and I click what? The contact us button. That whole sequence that I've done, it's going to be captured in what they call a trace. You understand? Most infrastructures do not record traces, but most people actually do because they need analytics of the parts of the website that people actually visit often. Then they can now use it to make business-driven decisions. You get? So that's what traces are. Traces are a record of the journey of a single request through the system. You understand? A single request through the system. You can go from front end. So now what people now use traces to do now is that journey that it goes from the front to the back. For example, now, when you do your www.com, you can, when you pinpoint your site, you go down, that process that it goes to where the application is, probably when it gets to that application, it gets from a database, feeds from data from a database, and returns it back to you. It can serve as one trace as well. So people use traces to get latency errors. For example, they want to build a system where they want it to be fast. The request and return should be fast enough. They implement traces to be able to monitor how fast the request goes and or not, basically. Yeah. So it pinpoints bottlenecks and they also debugs latency issues. Now, for this our work, I'm going to show you metrics. CloudWatch has metrics, logs, and I've not explored the traces yet, but I know they have metrics, logs, and dashboards, alarms. You can also create alarms as well. So let's do that. This is the metrics dashboard. It shows you everything you need to know. Let's go back to EC2. Let's use our setups I've set up. Was not set up. No matching instance found. Probably made a mistake. Still betting capacity. Okay, we got that one later. So now let's do launch instances. Let's launch a very, very brief instance. Let me show you. Let me see. All these ones are not important. Let's launch this. All right. Successfully initiated launch of the instance. Okay, let's go back to CloudWatch. Let's take note of this. Take note of this thing. We'll go back to CloudWatch now. Let's go to metrics, all metrics. We go to EC2, showing you how to create a metric. Go to EC2. See EC2 here. This because our system is an EC2. Now you see per instance metric. That means we're setting it per instance. So that one's by auto scaling group. We'll set this one per instance. Then you will now see CPU utilization. So we're setting a metric to show us the CPU utilization of the server we just created. Let's play this thing right. All right, so you can see. We now paste that our instance ID here. Give us the exact instance that we have created. Now you can see KCLSG, which is what we just created. All right. You look at the name here. So now we want to set a metric that CPU utilization. So we already set this metric now. We now create an alarm. You can see specify metric and conditions. You can see this one, nothing is loading here because the instance is still coming up. By the time it comes up now, you will see like graph stuff here because the utilization is very low. You can see statistics average period 5 minutes. This 5 minutes means that it should be checking every 5 minutes. So this particular alarm should check every 5 minutes and then give. So it's like when you're boiling rice and then you put something inside the rice to check if there's still water under the rice. Exactly. That's what this is. So it goes into the data, it goes into the instance and then check and then take the record of the CPU utilization and then publish it here every 5 minutes. You can set it more than that though. I set it for every 15 minutes. But most people want granular details. You get, like me personally, I set it for 5 minutes or 1 minute set. But 1 minute give you, it's always triggering. So let's just say 5 minutes. 5 minutes is okay. Static means that the value will be static. Now, whenever CPU utilization is greater than 80%, this is what to use to configure the alarm that I want to configure or configure the auto scaling action. Then to go to next, you can see select an existing topic, create a new topic. You can see default CloudWatch alarm topics. I'll use my email. Please see me down, send it. Don't push number and start copying it. So most of you will be sending me emails to mark your assignments. I'm not going to call the person's name. The person knows herself. Create topic. Now I've created that topic. Next. Alarm name. I'm not setting CloudWatch alarm. Next. So yeah, it will preview and create. Now you can see the red is showing 8. You can see now it's very minuscule. If you chook your hand here, you can see 9.0%. That means it's very, very small because it's a new server now, it's a baby server. I'm not going to create this though, but I just want to show you. See, very, very small. That means we're trying to tell you that if it goes anywhere past this 80%, you can see that this is very, very small. If it goes anywhere past this, you sound an alarm. You understand? So that's what this whole setup is, basically. Then you click on create alarm. I'm not gonna create that. So yeah. The next thing is dashboarding. So if you don't want to create alarm, you just want to be viewing, watch me. Just the watch them. You can go to dashboards. And we can go to create dashboards. I love creating dashboards though. I enjoy it. Dashboard themes, CloudWatch, dashboard. Oh, underscore. And this dashboard now, you now go back to the metrics. Where I use metrics, tell you line. Next. Same thing we did here to push out the metrics we use. EC2, for instance, metrics. Most short. Let's really write this time. ESS. I can see to tell you to create widgets. You can see the dashboard is giving us things like this. So it's very, very small. Very, very, you have to set the God's name in the create widgets. Very, 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 very small. I feel like I should do this thing with a large data set. So yeah, any questions so far? I'm sure now most of you now most of you now know what to work for. You can actually decide to specialize in just core monitoring. It's good, it pays very well. So we said they will pay you to create dashboards for large scale systems. Yeah, look at it. This is just a very basic dashboard because it's just one instance. You can see the timing now. What's the time? 92. This one is going. This one uses UTC. We don't hear in Nigeria by UTC plus one. Uses UTC. So it's 7 o'clock. And it's telling you that it is what 8 points. Or rather, see the time it's giving you. It's even down here, sir. 3.63%. So if I start pumping load and pumping high traffic into this instance now, you'll see that it will start doing, you know, all those things that you see in Hollywood movies, start doing up and down, like crypto charts. Yep, that's what it is basically. So this is just the most minuscule setup. You can set it up for large scale systems. You understand? So yeah, any question? You know my happiness with this class, people don't like to ask me questions and people still do good job. If people don't ask me questions, I not get English in text. That's when I'll not be a very But y'all don't ask me questions, but you still do well in assignment. Most of me, a good number. So I feel like I'm doing well to tutor. But like you know, I always break down things in the most minuscule versions.
So I have a question.
All right.
Regarding the load balancer, the application load balancer.
Okay.
So it must be that we must be using multi AZs first.
Yep.
Okay, if we are not.
There's no need for using a load balancer if it's just a one single availability zone now, because if anything goes wrong with that availability zone, your entire this thing there, to go off. So load balancer load balancer promotes the concept of high availability. You understand? What's high availability? When one region goes down, when one zone goes down, you should switch to the other zone, basically. So it does not make sense if you now have to, it won't even allow you to create an instance, a load balancer with 2 instances in the same zone. It won't even allow you, basically. You understand?
Yeah, noted. Thank you.
Yeah. Any more questions? So from next week, we're talking Terraform. Prepare your code editor. Download VS Code. I'll send, can look for it, but I'll try and send the installations to Terraform this weekend. I'll also send the how you will now, those of you that have AWS accounts, you're going to have to create, and that one is a tax I'm giving you. I'm not going to do that one for you. Create an IAM, go and create an IAM access key and secret key. Go and look for it, create IAM access key and secret key, and attach it to your local machine, so that when you write code on Terraform, it should appear on your AWS. Set the right permissions for it. I'm going to ask for you to all right, so since that there's no question,